All right. So everybody should be here. Let us just double check that. Make sure the stream is working. Can you all hear me? Okay, good. And you can see the IDE IntelliJ? All right, sounds good. So I wanted to demonstrate you how to solve the issue that you're all having of parsing the text. And as you can see, it's doable. And here's the logic for that under Parsing Logic. My recommendation is to make a class like this. And make it so that you get a array of strings. Once you have that array of strings, then you parse them and you convert them to the values that you need. So that is just a short teaser, basically, for the homework assignment to make you wish I showed the logic, actually, to be honest. But you can easily parse. It is possible. You can brute force this, or you can be clever in how you solve it. If you Google how to solve it, you can find some good solutions online. So we'll leave that as is. But today I wanted to talk about two things in particular. I wanted to go over some of the questions that how I prepare them for quizzes and for exams, and particularly for this course. And what I did was I went to the book. I went to the end of chapter 6. I find it more useful when making questions to work backwards, but that's just me. And what I did was I created some sample questions for you. They are now posted on, let's enter student mode, course content. Yes, you can see it. So they are on Blackboard for you to take a look at. Each question is divided by these dividing lines, and as they went, I got lazier and just made less of them. But estimated how long I expect it would take for you to solve it during an exam or a quiz. Some of these, like this one, answering these true-false, shouldn't take you 5 minutes, but I was being very generous with time expectations. So let's work our way through these. Can you create a static method called by another class with the following code? Private static void main, string args, and have that syntax. Does anybody have a guess? True or false? Remember, there's no trick questions unless I specifically am making a trick question. But yeah, there will be some that are slightly trickier, but none of them will be true trick questions. Does anybody have a guess? Okay, if you say false, why do you say false? Correct, private. Protected could be called by another class if that class extends this class or whatever the class that this is in. So package private, which would be no declarative, would allow package or classes in that package to call it, and public would allow any class to call it. So private is correct. Now, the following primitive types can be promoted, cast without loss of data. Int to float. True or false? There is a table in the book that tells you exactly these. True, okay. What about float to int? That's true, false. What about these two? Float to double or double to float? Well, let's go the first one. Float to double. So somebody said, I forget it, if float or double holds more info. Well, you need to remember that. That's important. That'll be on the test. I can guarantee you. Almost all of these will be on the exam. So, yep. And that's the point of me writing these questions like this, is to let you have a feel for the type of questions that I write and make you understand you have to know this material. I'm not specifically covering all of the Java. Float can be cast without losing data from, or float to double, that is correct. And double to float cannot, because double holds more data. It's whichever one holds more data, can you cast it. Long to float. I wonder if I can find that table. Yeah. I'll tell you after this. Long to float. That is true. This table is on page 118, just so you know. Long to int would be false, because longs are hold more data than ints. The double pipe, that character is called the pipe, by the way. The double pipe operator, is it an inclusive or exclusive operator? Well, this question relies upon you knowing what that operator is, and understands you knowing what an inclusive and an exclusive operator is, and being able to tell which one this is. So there's multiple levels to this question, even though it's a true and false, or essentially a true-false. Compare and contrast the difference between inclusive and exclusive operators for and or. This would be a short answer. You would need to write at least 2 sentences. That's like literally the definition of a compare and contrast argument. So, give you 3 to 4 minutes estimated to solve that. Explain what a break statement does inside of a while loop. Compare and contrast the difference between prefix and postfix increments. So prefix versus postfix. These are nuanced questions, I get that, but the answers are in the book. No, the pipe operator is an inclusive or. If either one of them is true, it will be true. Java doesn't have a simple Boolean exclusive or. It has a bitwise exclusive or. That's the caret symbol, I think. I almost never use it. I always have to look it up. I don't use bitwise operations, to be honest. You do need to know them, but and I would at least memorize them for an exam if I was being quizzed on it. But bitwise operators aren't as often used anymore. So, explain the scanner class. Explain what the scanner class is used for. 1 to 2 sentences. Okay. Compare and contrast primitive types versus reference types. So these are some deep questions. Prefix, postfix, inclusive versus exclusive operators, understanding break statements, and there'll be others in there. But I think this is a good mix of some true and false, technically a multiple choice question here, some short answer, simple explanation, short answer. So that's where that all is going for. Are there any questions about the format of how these questions are going to go? And literally, they're going to be out of the book. I'm not going to make up any questions other than the 4 design patterns, and I'm going to pull those from their respective Wikipedia pages. So I'll make a list of everything. So yeah, you need to know chapters 1 to 6 inside and out as best as you can. Now, are you going to have to remember that forever? Yes and no. Some of it you'll forget the specifics of, and then you'll just inherently remember. And then if there's a question you might look up in the future. There's that famous quote of Einstein, you don't have to memorize anything, you can always look it up. That's true. How am I going to deliver the test? It will be through Blackboard. But once you start getting more experience with developing with Java or other programming languages, you stop having to remember. I'll talk about the specifics of the timing and whatnot later once I decide the exact format of it. I haven't figured out exactly how I'm going to deliver it. It will be through Blackboard. But my point was, you will instinctively remember most of what these are, because most, it will be the 28th. The exam will be on the 28th. We'll have a quiz and a new assignment on the next week and the week after, so that you can get practice actually completing the quizzes and doing them in person. And then those will be on the 14th and the 21st, and then the 28th will be the exam. I did push the exam back a little bit further than I had on the course syllabus, but that is because I wanted to make sure that we covered the majority of the basic syntax for Java first. And we're not covering all of it. There's a lot more to it, like threading and exception handling and even the default interfaces and stuff like that. That I don't believe is actually covered yet in the book. But I wanted to expose that stuff to you so you were aware of them. So that's why I was specific in saying that the exam will cover chapters 1 to 6. That way you don't have to guess about, oh, he showed us this cool thing. Like today I'm going to show you threading. That will not be on the exam. You will need to know it by the end of the final. But I'm not going to ask super in-depth concurrency questions like I would in a, what was the course number? 4819. Parallel and distributed computing. I'm not going to ask you those types of questions, but I'll ask you simple questions at the final exam about that, but not for this exam upcoming, so you don't have to worry about that. Does that make sense to everybody? So you have chapters 1 to 6, this type of format of questions, short answer, true and false, multiple choice, and there might be some where you have to write some snippets of code. And then it'll also cover the design patterns Does that make sense to everybody? I think that's pretty straightforward. You have 3 weeks from today to study and prepare. And like I said, you needed to read the chapters for a while now. So I'm trying to be very fair with the examination methodology. So my goal here is to teach you this material, not to grade you harshly. So I'd rather you all, if all of you deserve A's, you'll all get A's. That's fine with me. I have no problem with that. So, any questions about the sample quiz exam questions? If not, we'll move on to the coding portion. I'm going to cover a new concept today. A couple of them, actually, that are kind of often tied together. All right, so we'll close that out. And we will run this. And you'll notice I hit run, and it is technically running right now. Then it just finished. Today, we're going to start talking about threading. So how do you run something in a background task? Now, in Android, there are strict requirements of what you can and cannot do in a UI thread versus a background thread. But on Java, we can basically skirt that line. So if you'll notice, I'll run it again. 1, 2, 3, 4, 5, and it finishes. And I know it's 5 because you come here, and this is a bunch of gobbledygook. I know that. We'll explain it here in a minute. Oh, excuse me. Yeah. So this can be simplified, but this is technically what the code is saying. So let's run through it. Let's ignore this for right now, and let's focus on this. Everybody knows what a thread is conceptually, I'm going to assume, right? Like you have multi-core processors, and they can run, generally now, all processors can run multiple threads. Okay, I'll get to the override question here in a minute. Let's talk about threading. Well, okay, let's cover override. Override is meaning that this method is overriding a default method that is declared in runnable. But in runnable in particular, it is a functional interface that only contains the run method. So we're creating a new instance. Oh, excuse me. We're creating a new instance of the runnable interface with this logic inside the run method. I'll explain all of this here in a bit. Let's talk about threading. So you all know what a multi-core processor is. The more cores, the more work you can do at the same time, right? Everybody knows that. I'm assuming that's just general knowledge for people at this level of software engineering courses. If you don't, that's basically what it means. The more cores that you have, the more threads that you can run at the same time. And there are processors, most of them what we use nowadays on modern processors for desktops. Every core can run 2 threads. Server stuff can be increased to 4 or more threads. So, does that make sense to everybody? So I'm running right now OBS, Discord, Winamp, IntelliJ. Each one of these applications is running in at least one thread. Does that make sense to everybody? It's sort of magic hand waving. You'll learn more about this in computer logic and organization. And then operating systems, obviously. But what it means is I can create a thread to run parallel to my main thread. Great, I can divvy up work. Let's look at this. Thread. What is a thread? Allocates a new thread object. Allocates a new thread object. This constructor has the same effect as yeah, we'll skip the rest of it. It's not required. But the important part is the parameters, the target. The object whose run method is invoked when the thread is started. If null, it doesn't do anything. So we have to pass in a runnable. Here is a runnable. I called it R. It is a new instance of runnable. It overrides the method run, and you put some code in there. Now, let's cut this. Run this. And it didn't do anything to us. It just printed this out and then instantly process finished. Well, that's because this is a very bad use of a thread in a runnable. If you want a thread, you're generally going to, if you're going to be running something in the background, generally you're going to be running something that takes a long time. Well, what takes a long time? A lot of things. Large mathematical computations, waiting for input from the user, things like that. Networking requests, sending data to or from input and output, so sending data to the speakers, etc. So here is the main line of code where I made the thread sleep. What does a thread sleeping mean? Well, it goes to sleep. Programmers aren't creative. In naming, at least. So it sleeps for 500 milliseconds, which is 5 seconds. This try-catch is interesting. We haven't covered this yet. Does anybody happen to know offhand what it does? No? Okay. So, let me delete this. And you'll notice, I mouse over this, unhandled exception. java.lang.interrupted exception. Catch interrupted exception. Print stack trace. Oh, okay. Well, what this does is, if this thread.sleep gets interrupted, let's say for some reason the operating system says, oh, well, you can't run anymore, I'm sorry. You got closed by the super user or the kernel. Well, then this can't finish. If this can't finish, it would throw this interrupted exception. If an exception is thrown and not handled, the application will crash. So, throw I don't even know if that will Oh, here's a better one. It won't even let me create an example that will crash. Let's try this, though. Int I equals... Okay, now notice we mouse over this and I called a method on integer.valueOf. So it explains it, what it does. Okay, parse int. Fine, they both do this same thing. I guess parse int's the newer version of it. Number format exception is thrown. Oh, okay. Well, is this a number? Well, let's see what it does when you pass a number to it. Program runs fine. Let's try it now. Application crashes because there was an uncaught exception. Exception in thread for input starting hello threading. And you click here and it'll take you exactly where the exception happened. So we'll cover exceptions more. I just sort of wanted to brush up against them and make you aware of how you handle them. As you saw, throws number format exception. We come down here. Try. Catch. Number format exception EX. Exception. Okay, that's weird. Oh, I see. Yes. I outsmarted myself. There we go. Yeah, I forgot something. This is running inside a separate thread, not the main thread. So the exception here wasn't being caught inside this thread. It was being handled by this thread, which we run this again. This is why concurrency and multi-threading can be challenging. You always have to remember where exceptions can occur, things of that nature. So, anyways, this is getting more into more complexity than I wanted to really get into. I apologize. But, there. We run this. Wait 5 seconds. Says hello threading. And exits successfully. Okay. So, sorry about that. But anyways, it's catching the interrupt exception if it happens, and then it's printing out the stack trace. And then when this finishes, it will print out the hello threading. Now we do this, put this here. What do you think is going to happen? 1, wait 5 seconds, hello threading 2 pops up. So whatever happens first, because there's no sleep before it, happens immediately when this thread is able to start running. Then the sleep for 5 seconds, and then whatever happens after the sleep is executed. Does that much make sense to everybody? Now the syntax, you're just going to have to trust me on, and you just learn it. It's ugly, but it's not that hard once you remember it. And there's some much simpler syntax now. Once you've already learned what this is really doing, you can simplify this dramatically. So we will copy this method. We will call it test2. If you hold, whenever there's a little line over here, it's saying you can improve this. You hold down Alt and Enter, and it'll bring you up a option of what you can do. This is what's called a Lambda expression. Lambda expressions, if you go on Wikipedia and you Google Lambda or functional programming and Lambda expressions, it's a super high-level math concept, but basically the reality is it's just shorthand for creating methods and objects inside code for us. There are some differences, but we'll get to those later. It's called scope, but we'll cover that later. And you'll notice also I don't have to well, we'll start here. If you'll notice, what did I do here that's a problem? Oh, okay. IntelliJ was just being weird. That's interesting. Oh, I see. I didn't grab this much. I don't have to create a separate R runnable. I can just create it inside the declaration here. Okay, that makes sense. And also I can do this. I can just start the thread immediately without naming it. Now, if I showed you this, this is a lot more, I'll call it gobbledygook, than, actually, we'll just delete all of that. This makes a lot more sense, in my opinion, to new developers, because you know that it's creating a new runnable object of some type. In this case, it's an interface. You're creating a method, you're overriding it. You're having your code in here. This runnable is being passed to the new thread, and then you're starting the thread. Does that make sense to everybody? This much at least, right here? It's fine if you have questions. I know it's a lot to throw at you all at once. Okay. Let's go ahead and do attendance. Everybody that's here, go ahead and say here. Okay. So, does anybody have any major questions? I know this is a little farther than what we've done before, but it's once you start having threads, you can start doing a lot of interesting things, particularly when it comes to design patterns, and I'll call them design concepts that are used to build patterns. Particularly a thing called callbacks, things like that. So, okay. This is a pattern that I use all the time at work, and so I realized that this would be a great thing to teach you here. So, public interface callback. On click. Okay. We're just going to pretend that, well, technically this public is needed logically, but it's unnecessary to write it because it's redundant. Does that make sense? Like all interfaces, this method, all the methods you have in here are public by default. I personally would still write it. I'm in favor of having redundant information personally, even if it's not required, as long as it's not excessive also. I think putting the public in there is good, but technically a lot of editors and a lot of other programmers don't. So that's a personal preference type of thing. Because my opinion is if you put public in there, it helps with junior developers who are learning Java, who might not know or remember instantly all the time that all these methods are public. So, callback here. Interesting. And we're going to fake this a little. We're not actually going to have clicks, but just pretend that there's a UI and we're clicking. So, now you notice threadlogic.callback. I have a callback here. Callback equals new. Okay. I run this. What's going to happen? Does anybody have an idea right now? Not a trick question. Nothing. Well, nothing different. This callback is never used. Okay. Somehow we have to use this callback in our ThreadLogic class. Notice it gives me options. This first one here is the one I want. Well, why is there a problem now? Before I click this, who can tell me what the problem is? I've changed the number, order, and type of parameters for this method. Why is there now a problem in my program? That's correct. It hasn't changed in main. And what I'll do is I'll move callback above here, and I'll pass it in. Notice it wants me to replace this with a lambda again. Now, is this a huge code savings? Look at that. That is 1, 2, 3, 4, 5 lines of code down to a single line. But if you don't know that lambda notation, this is much clearer what you're doing, and this is much shorter. And personally, a lot of times I would prefer to have this for junior developers and this for senior developers. Does that make sense? This is a what level of development staffing am I going to be having working on my project? Eventually, you're going to want all of your developers to understand this. But in my opinion, this notation isn't super friendly to new developers. Whereas, this is much more. Let me put it this way. Everybody can agree that this is much more understandable for you right now than this. I think that's obviously true. So we'll leave it like this just so you get some familiarity with it. But know that all we're doing is we're creating a new callback, and that there is hints at that right here. We're not passing any parameters, so there's no parameters in here. This is the lambda notation. I personally prefer lambda notation to have this. I think this is much clearer. Technically, you don't need the brackets, but it is what it is. And there might be a scoping issue there when you use brackets. But when you have brackets, you can do 2 lines of code. Where you can't do 2 lines of code is 1. And this, once we start talking about Git and how you track changes in your code, nothing's going to change, but it works. We delete that, we run it, it's still going to work. But it's telling you to get rid of these curly braces, and I think that's actually detrimental. But regardless, we'll leave it as that for right now. And later in the class, when we start explaining Git, I'll show you why it's detrimental to get rid of it. Okay, we now have a callback. So we'll get rid of these text inputs. Callback. Now, what can I do on this callback? What methods do I have available to me? I'm showing you on the screen. Not a trick question. Just take some thought of understanding what is actually going on now. Yes, you're right. On click. On click. And callback was called. Well, callback, you'll see. Yes, something I notice. Now, void. Now there's a problem. This lambda notation only works for And that's why I still prefer this in a lot of cases, because that you see that has the red line. I still prefer this in a lot of cases because it helps with development speed, because now I know there's an error here. Alt, enter, and it brings up methods that I can do to fix it. Implement methods. It's going to tell me which methods I'm not implementing. We run this. It's going to tell me I'm calling onClick, not onClick2. OnClick called. And it works. So this is the concept of a callback. What we do is we have an interface, and we require an implementation of that interface to be passed as a parameter for a method. Now, we could also have callback. There. You can actually, and if you don't know what I just did, what I did was hit enter here, Alt, insert, and I came down here to generate a getter and setter for mCallback. Now notice mCallback, it's warning me I can delete it because it's not used. Well, that's fine, but I plan on using it possibly. But also, it used the same name as what I used up here, instead of using what we would consider better naming, like this. Because these are public methods, and this is a private object variable. M is for my. It's just convention. Newer programming languages like Kotlin move away from this. And you have the callback like this. So you get the callback, you return mCallback, you set the callback, you use it like that. But down here, this callback, notice, I click this, I click here, and this callback highlights. Why does it do that? As a hint to me that this is the callback that's being called. We could also do I can run this right now. There's going to be a problem. On click, mCallback was never set. And you can actually reuse the callback object. Callback, click, callback, click. Now, this might seem odd, but who here has ever used the Facebook app, for example? On Android, at least. iOS, I think, works slightly differently. Same general concept. Well, on Android, you have what's called a recycler view. And that's the thing that scrolls, allows you to keep scrolling. And you set a click listener. Oh, look. I called this a callback. I could also call this click listener. Notice it changed automatically the variable names for me too. Very helpful. and I could have an onClick. And every time you click on one of the posts, it knows what you're clicking on. But how does that happen? Well, we don't have to make I'm just making these up. You can pass values in the callback also. I'm going to change this to 2 for simplicity. So callback was called 1, 2, 3. Callback was called 2, 3, 4. So you could know which item you're clicking on. So you can make one click listener, one callback, and then each item you're clicking on, you can know the unique identifier and launch the new correct window for that unique identifier. Does that make sense? It's a little bit abstract, but I want to take the time to start talking about this concept of a callback and where it's actually used and how and why it's important. So you can pass parameters into the callback. In this case, I called it click listener. You can pass click listeners as a setter and have a variable, a private local variable for that. Or you can have instance variable, or you can have it pass as a parameter for a single method. And then you can make use of it by calling it and passing the value up the chain of click listeners. In Android, you actually have a bunch of chains of listeners. And what that does is you could have a separate class down here, and you're actually calling a listener from it is passing the values up to this thread logic, and then finally back up here. That's a little convoluted, and I'll explain that later. But doing this pattern allows you a lot of flexibility so that you can subdivide what all classes can see what all other classes, and thereby reduce the amount of the word is escaping me, but it's reducing the amount of scope of number of classes that need to change when you change one class, essentially, is what that means. It starts with a C. It's not cohesion. It's not cooperation. See, this is horrible. Coupling. Thank you. The concept, I just couldn't think of the name. It's coupling. So you want to have loose coupling between these concepts. And that might be a little abstract, and I understand we'll get to that, but I just want you to understand what we're talking about and why. Notice I'm only importing a single class from here. public void. Okay, so what this does is I have a class, takes a callback of this, so it's logic2.callback. I can type that here. Oh, let me rename that. Uppercase L, good programming practices. Logic2.callback. I can come here into the thread. Oh, yes. I'm being silly. Yeah, we have time. There we go. I was trying to rush too quick and I wasn't thinking ahead. So now this is purposely convoluted. Yes, I know it's done that way on purpose, but I'll show you why here in a second. Notice I'm running this over and over and I'm getting different values. But my main class is only ever calling thread logic. That's convenient. I don't have to know about logic 2 in my main thread. Let me rename this. There. My main thread, or my main class, only has to know about thread logic. It doesn't need to know about logic 2. It's decoupled from logic 2. Does that make sense? Why you would want to have that? So any changes I make in logic 2 are only going to affect this class because inherently, because they're in the same package, it can use logic 2. Doesn't need to have an import. I come down here. Now, could I just have easily made Oop. Helps when I type correctly. And then in here, I don't use this callback. I just call the method and return it. Yeah, I could have done that. But where's the fun in that? No. There's use cases where this indirection of multiple times through callbacks is beautifully simplistic and really, really useful. I'll show you an Android example where you what's called an adapter for an array list, or and you use this chaining of callbacks, and it makes your code so clean. It's a little convoluted to understand the first time, but it's really nice once you get it working, because you have a very small coupling of your code to other classes, so you can change individual classes and only affect maybe one, maybe two other classes. Whereas if I made some like global interface that passes up ints, and then I add a new class or a new method to that interface, I might have to edit all of my classes in my project. Does that make sense? Where the rationale of you're not wanting to highly couple your classes together, and you want to keep them isolated. Does that make sense to everybody? Does anybody have any questions about that? And or this idea of callbacks? This isn't technically a pattern as far as I know, but it's a component that is used a lot in patterns. Are you all still there? Can you say anything? That's the one downside of not having you in class person. I can't see you nodding your heads. Because I know at least one of you was nodding your head answering me. Don't feel like I'm calling you out. Yeah, no. I just want you to understand the general concept today. If you're fine and you're lost otherwise, that's fine. Like, I did a lot of, like, magic hand waving. This works the way it does. Trust me, type of stuff. So, and that is the point that there's a GIF that I don't understand. Oh, I guess you could play it. Oh, somebody nodding their head. Yes, very funny. So, yeah, that's the point. This is convoluted. I get that. Like, this is ugly. This is just painful. I get that. It's not hard once you start breaking it apart. If you start breaking it apart like this, into its subparts, it makes a lot more sense. Be like, oh, here's the part where it sleeps. Okay. Well, here's the logic callback. All right. It's creating a new logic 2 callback. And when it hits the callback, like, oh, I get lost here. Oh, okay, that's fine. Like, just the concept of the callback is an interface, generally interface, could be an object, that is being called, and you're getting the response, the signal, the event. It's generally used in event-based systems. Like, notice I called it on click. There was an event in the system. You clicked the screen, an event triggered and the on call or on click or on long press, etc., the event was triggered and the event happens and propagates up through the system. So my naming was precisely because of that. So, but I just wanted to show you some threading and talk about callbacks. Feel free to rewatch this. It's not that hard once you get used to it. The first couple of times doing it yourself, even myself, when I tried to figure out how to do best practices for Android recycler adapters and things like that, and view holders, there's this entire pattern called view holder pattern and the MVVM pattern and other things like that. It got really convoluted and complex the first couple of times I did it. Now it's literally second nature. I just sit and I just bang it out real quick. So I just wanted to expose you to this, and today I think we had a pretty good class. Today we covered when the exam's going to be. You're only halfway through the period for your first assignment, the time period. It'll be due next Thursday, I believe, at maybe midnight or start of class. I'll have to check. I don't have it up checkable right now. We covered what type of questions, the format, the methodology, how I'll figure out the questions. I will still make a study guide for you for the first exam to cover in particulars what I will definitely be covering. There will be more assignments incoming. Assignments will overlap. They won't, because I'll give you a long time on them. They'll overlap a little bit at least. And then there'll be some quizzes before the exam, and then to get you used to doing those. Those will have to be done during class, so you'll need to be present. And there'll only be a small time window for those. And then the remainder of the course, we're going to be talking about stuff like this. Actual software engineering concepts, software design. Now, this click listener or callback concept is I'll call it a component to design patterns that you will get very familiar with. Okay, it is midnight for the first assignment. So at this point, you should have the assignment completely done, ideally, other than the text parsing. If you're having difficulty with the text parsing, that's fine. But you want to complete the rest of the assignment. Make a different class. Put that code elsewhere. And just like magic hand wave, like this should work. And complete the rest of the assignment. The output, the actual calculations, etc. Do that. If you parse it into 3 strings, you'll need to convert some of those strings to numbers. You'll need to make sure that they're actually formatted as numbers properly. You'll need to do some type of error output if the numbers aren't numbers or they're not mathematically valid operations. And then that'll be one section of code. Subdivide this code to make it as expandable as you can, basically. That's reusable, expandable, editable, things like that. So I think that's it, basically. I think we had a pretty good class. Hopefully you learned some new concepts today. Again, the stuff covered today will not be on the exam, so the first exam, so don't worry about that. I do know it was a lot of, I don't quite understand what's going on, I hope I get it later type of thing, so don't worry, I get that. Let's see. I'll start linking some articles like loose coupling, Wikipedia articles, in the class section for on Blackboard. I'll also link the design patterns that we're going to cover in this course. I'll start with the 4 on exam 1, so you don't get confused. Are there any questions? Did the class seem to go pretty well for everybody? I seem to like this format. It seemed to flow a little bit better than some others. Okay. Yeah, go ahead. The questions that I put in Blackboard so far for the exam and quiz mock questions, those will probably be on the exam. So make sure you know those at the very least. But go through the chapters and look for questions that you think are in similar vein. The key points. Will you know what I think are key points versus what you think are key points? No. So does that mean you actually have to know all of it? Kinda yes. But this is sort of the point of the reason I did it this way, is it's a good evaluation for you to understand the language and to understand how to my methodology of creating questions. So we still have 3 weeks until the exam. Is that correct? Yes, 3 weeks exactly. So if you start reading the book, or hopefully reviewing the book, you've already read it, is my hope. You start reviewing the book and there's questions or there's statements in the book that seem contradictory to you or you don't understand, bring them up. You can put them in the general discussion, or I think there's actually a channel for Java language questions. So if you have any questions about the language itself, feel free to put them in there. And I think we'll be good. And I'll go ahead and let you all go so that I don't run into your time for other classes. Otherwise, we'll go ahead and finish here. And you all have a good evening.